So here is some calculus practice that is relevant for the FE exam. And the first problem we have is we want to find the value of B for a line that is tangent to this parabola that we have here. And I've kind of made it easy by giving the plot here. So what we have is we have this parabola, which is plotted, and then we have this tangent line. And so what we want to do is we want to find B, which is the y-intercept here of this line. And the way that we do that is we start by taking the derivative of this function, which gives us the slope of the function as it varies along x with different values of x. So now that we have the slope at each point of x, what we want to do is we want to set the slope equal to 2, because that is the slope of our tangent line here that we're dealing with. So we'll set 2x minus 6 equal to 2 and solve for x, which is 4. So now we have one point here, which you can see where they intercept. Where they meet is at 4, right there. X equals 4. So that's 1 point. And now we need to find a y value. So what we do is we can plug back into our function here, our value of x. So we can say f of 4 equals 4 squared minus 6 times 4 plus 2, and that will give us our y value here. So what we get when we do this is 16 minus 24 plus 2, which equals negative 4, not negative 14, negative 6. And that looks about right according to our graph here. This is negative 6. So from there, now we can plug back into our equation of the line, where we have y equals 2x plus b. Now we have negative 6 equals 2 times 4 plus b. And we solve for b and get negative 14, which is right here. Okay, so that's our final answer. B is 14. All right, for the next problem, we are just going to take the derivative of this function here. And in order to do this, we need to use the product rule and the chain rule. So we start with the product rule, which is the derivative of the first function times the second, leaving the second alone, and then the first function times the derivative of the second function. So the derivative of this first function here, we're going to use the chain rule, take the derivative of the inside, which is 2, then we'll multiply by the derivative of the outside, which is minus sign, and leave the inside alone. We multiply by the second function, and we add the first function times the derivative of the second function, which is the derivative of the inside, which is 4, times the function there. You get 4x. Okay, there we can take out e to the 4x, and actually 2 e to the 4x, and we can rearrange to get our final answer. Looks good. All right, number 3 is going to be find the area between the two curves y equals minus x squared plus 1 and y equals x plus 1. So if we look at these functions, which I plotted again here, we have our top function, which is the parabola that is here, and we're going to take the integral from actually where they meet, so where they intercept each other, which happens to be on the axes there, and then we'll take the integral of our blue function here, get the area underneath, and when we subtract that away, what we're left with is the area in between the curves here, and that's what we want. Okay, so the first thing to do is to figure out where they actually meet, and the way that we do that is we set the functions equal to each other. So we need to find out where they actually meet, and we've set the functions equal to each other. So we have minus x squared plus 1 equals x plus 1, and now we solve for x. So we can have x squared plus x equals 0, and if we factor, x will equal 0 and negative 1. And that looks right based on our graph. This is negative 1, and this is 0, 1. Okay, so now these are our bounds of integration. So when we integrate, we're going to integrate from negative 1 to 0, and we'll integrate the top function, which is minus x squared plus 1, subtracting the bottom function, x plus 1. Then when we integrate, we'll end up with this, and these x's will cancel, and so our final will be x cubed over 3 minus x squared over 2 from negative 1 to 0, and when we plug in, we get 0 minus So then what we will get is this negative will come down, minus, and we'll have minus 1/3 minus 1/2, and our final answer will be 5/6, and that is the area in here. But 5/6 is just whatever units these were here, which we didn't give, but that's the area. 5/6 units. For this problem, we're just going to evaluate the integral of secant squared x minus 1. And what we'll get is the integral of secant squared x is tangent x, and the integral of 1 is x. So we'll get tangent x plus x, sorry, minus x. plus c. That'll be our final answer there. So for this problem, we have the velocity of a car is given by a function. Find the total distance traveled from time of 0 seconds to 4 seconds. And what we have to do is integrate this function from 0 to 4. But the reason that we do that is velocity as a function of time is equal to the change in position with respect to time. And if we solve for the change in position, we basically have a tiny change in position is equal to the velocity at that instant times a tiny change of time. And so we need to add up all the tiny changes of distance. So we'll integrate velocity as a function of time with respect to time. So that is going to be our integral from 0 to 4 of 3t squared plus 2t with respect to time. And here we'll just get t cubed plus 2t plus t squared from 0 to 4. So what we have then is 4 cubed plus 4 squared minus 0, and that would be 64 plus 16 equals 80. So they went 80 units of distance in 4 seconds. Okay, number 6 is that there's a container here that has a small hole in the bottom, and the water is coming out as it's being filled in, and it's being filled in at 0.16 cubic meters per minute. And we have basically a water level that is a depth d, and the water is coming out at 0.36 d squared per minute, cubic meters per minute. So what we want to know is, after time of t minutes, as the container is being filled, and we have a volume of water V in cubic meters, we want to show that the change in volume with respect to time is equal to this function here. Okay, so the way that we do that is we start by getting things in terms of volume. And so volume is equal to the width times the length times the depth. This is the volume of water. And we know that the width is 1.25 meters and the length is 1.6 meters and the depth is d. So what we'll end up with is 2d. So volume equals 2d, and then our inflow is equal to 0.16, and our outflow is equal to 0.36 d squared, but the trick is we want this in terms of volume. So it's 0.36, and to get this in terms of V, we need to solve d for V, and d equals V over 2. So V over 2 squared So that will be 0.36 times v squared over 4, which ends up being 0.09 v squared. Now our change in volume with respect to time equals the inflow minus the outflow. And the inflow is 0.16, and the outflow is 0.09 v squared. And now, to get it in this form, we just need a factor of 100. So we can just basically multiply this by 100, and we will get that dv dt equals 16 minus 9v squared over 100. And that factor of 100 comes in because we moved these decimals over. So we need that factor of 100 to get back to this equation. But it's the same thing, just a different format.